All right, we're on page 8 of the examples packet, and for this question it says prove ABCD is a parallelogram but not a rectangle. So we're not doing any new shapes here, we're just kind of continuing on with what we did with the old shapes. I've already plotted the points, so if you haven't done that yet, pause the video and plot the points. So ABCD is a parallelogram but not a rectangle. So we should already know at this point that to prove that ABCD is a parallelogram, that we need to show that opposite sides are parallel. So I need to find 4 slopes. I need to find the slope of AB, and I need to find the slope of DC, because those ones are likely parallel. So I'm going to do that first, and the slope of AB is up 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7, 8, up 3 over 8. And I'm going to count from D to C, up 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7, 8, up 3 over 8. So you can write a quick conclusion either underneath it or next to it, but basically AB is parallel to DC, same slope, and mark them parallel. Right, then I'm going to do the slope of AD, and the slope of BC. Again, in my diagram, they're across from each other, and they look parallel, so let's go from D to A. 1, 2, 3, 4, 5, over 1, 2, up 5 over 2, and B to C, or C to B, 1, 2, 3, 4, 5, 1, 2. Okay, so we can also say that AD is parallel to BC because they have the same slope. Okay, once I've done that, opposite sides are parallel, then I can identify this shape as a parallelogram. So ABCD is a parallelogram. Because both pairs of opposite sides are parallel. Okay, so we did this part. It's a parallelogram. Now I want to show that it's not a rectangle. So we have to think about what we know. If it was a rectangle, what would happen? Well, what would happen is we would have right angles at all 4 corners. And so like AD and DC would form a right angle. And we know that right angles are formed by negative reciprocal slopes. So if I look at, let's say, AD and DC, those 2 slopes, and I've already got them written down, but I'm going to write them down again. The slope of AD, I don't have to do any work, I already have it, is 5 over 2. And the slope of DC, again, I don't have to do any work. It's 3 over 8. Okay, so by comparing these 2 things, I can see that these 2 are not negative reciprocals. Therefore, they cannot be perpendicular. I'm going to write AD is not perpendicular to DC. We should put a therefore in front, because their slopes are not negative reciprocals. Okay, so since this is not a right angle, this cannot be a rectangle because a rectangle would have to have all 4 right angles. So our last thing that we have to do is write this in a conclusion and say why we know what we know. So our last statement, ABCD is not a rectangle. We actually already said it's a parallelogram up here, so we've already kind of taken care of that part. But ABCD is not a rectangle because 2 sides are not perpendicular. Okay? All right, so that does it for number 12. And we're going to move on to number 13, our last one. Again, I've already plotted it, so if you haven't, pause the video and plot it. Quadrilateral math has coordinates M, A, T, and H. Prove that quadrilateral math is a rhombus and not a square. So to prove it's a rhombus, the first thing I need to do is prove that it's a parallelogram, basically. So we start out the same way as before, the slope of the opposite sides. So AT and MH, this one's easy. I know that the slope of a horizontal line is 0, and the slope of a horizontal line is 0. So AT is parallel to MH, same slope. Okay, then I'm going to do AM, the slope of AM, and the slope of TH. A to M is 1, 2, 3, 4 over 1, 2, 3. Negative 4 over 3. And TH is 1, 2, 3, 4 over 3. Negative 4 over 3. Okay, so since these are the same, those are also parallel. AM is parallel to TH, same slope. All right, so mark them as parallel. And then say it's a parallelogram. Math is a parallelogram. Opposite sides are parallel. Okay, so to get that it's a rhombus, I have to show that consecutive sides are congruent. So I can pick any pair that share a vertex, so like AT and AM. So when I do that, let's just switch colors here. So if I find the length of AT is actually easy because it's horizontal, 1, 2, 3, 4, 5. I can just count it. Now I need to find the slope of AM. For that one, I'm going to have to do some work because I have to do Pythagorean theorem. 4 and 3. 4 squared plus 3 squared equals c squared. This is a Pythagorean triple. I know it works out to be 5, but 16 plus 9 equals c squared. So 25 equals c squared. So c equals the square root of 25. Oops, 25. And then at the end, I can just say that the length of AM, square root of 25, is just 5. Okay, so notice this one's 5, this one's 5. So I can say AT is congruent to AM, same length. Okay, so what I've done right now is I've shown that it's a parallelogram with consecutive sides congruent. And we talked about 2 classes ago, or really on Thursday, that this would then be a rhombus. So I'm going to say math is a rhombus because it is a parallelogram with consecutive sides congruent. All right, so we've got this part here. Prove that it's a rhombus, but not a square. Okay, so again, we would have to think about what would happen here if it was a square. Well, if it was a square, then I would have to have right angles, and so 2 sides would have negative reciprocal slopes, and they do not. So let's just, for my last part, write down the slope of AT, which is 0, and the slope of AM, which we already counted over here, negative 4 over 3. And so these sides are not perpendicular. I need to make my marker smaller. Okay, so AT is not perpendicular to AM, It does not, they do not have negative reciprocal slopes. Okay, so I realize this is a lot of writing here, but we're almost done. Bear with me. Our last part is to say that it is not a square because two sides are not perpendicular. It does not have all right angles. So you can do it right under here if you want, wherever, somewhere at the bottom. Our last conclusion, math is not a square. Because it does not have right angles. And that's it.